What if I told you there's a hidden geometric blueprint inside your brain, and it's shaping your reality every single second? Well, today on The Explainer, we're going to go find it. So here's our roadmap. We're going to connect the dots between a tiny piece of your brain, some 17th century math, people who can't forget anything, and a philosopher who somehow saw all of this coming. It's a wild ride, so let's get into it. All right, let's dive right in. And we're going to start with a question that gets to the very core of how you experience the world every day. Seriously, think about that for a second. You walk around a chair, you see it from a dozen different angles, but your brain just knows it's the same chair. How does it do that? How does it keep your world from feeling like a chaotic mess? Well, the answer lies in this tiny but incredibly powerful part of the brain. It's called the supramammillary nucleus, or SUM for short. Now, the best way to think of this little guy is like a gyroscope for your reality. It's this biological piece of hardware that's constantly working to keep your mental world stable and continuous, no matter how much your viewpoint shifts. It's your anchor. Okay, so we've got the biological anchor. But how does it work? What's the logic it's running on? Incredibly, the answer comes from a place you'd probably never expect: 17th century mathematics. On the left, you've got the SUM's job. It stabilizes the relationships between things as your perspective changes. On the right, you have a field of math called projective geometry. And what does it do? It studies the properties of shapes that stay the same, that are invariant when they get projected or transformed. You know, kind of like a shadow on a wall. It's the exact same fundamental function. One is biology, the other is pure math. And this isn't just some cute analogy. The point here is that this branch of mathematics isn't just like what the brain is doing. It's a direct model for the biological process happening in your head right this second. So here's where it gets really cool. Both of these systems, the biological one in your brain and the mathematical one on paper, they're both designed for one core purpose: to spot anomalies. They build a stable, predictable pattern of reality so they can instantly flag anything that doesn't fit, anything that breaks the rules. And this process shows you exactly how it works. Your brain is in this constant loop, right? It's generating expectations about the world through these rhythmic brainwaves. But when something unexpected happens, bam, anomaly detected, the SUM basically sounds an alarm. It amplifies that signal and tells your memory center, the hippocampus, hey, this is new, store this. That right there is how we learn, by noticing and remembering the things that break the pattern. Now, this all might sound a little abstract, but the theory gets so much more powerful when we look at a real-world human example. I mean, what happens when that anomaly detection system is cranked up to 11 and stuck there? You get people with something called HSAM. These are individuals who can tell you, with perfect clarity, what they ate for breakfast on a random Wednesday 10 years ago. Their memory is nearly flawless, and they are the living, breathing proof of this SUM system working in complete overdrive. And here's why their memory is so incredibly powerful. You know how for most of us, boring, repetitive days kind of blur together? That's a temporal compression filter at work. Well, in people with HSAM, that filter is way underactive. So for them, every tiny little deviation, every single anomaly gets saved in crystal clear detail. Nothing gets thrown away. And that's really the key. Our minds are built to forget the mundane stuff, but their minds act like a perfect, permanent record of every single moment that broke the pattern. They have a living library of anomalies in their head. So, we've got the biology, we've got the math, we've got the real-world human example. But here's the part that is just going to blow your mind. Long before anyone had even heard of neuroscience, an 18th century philosopher basically laid out this entire framework. We're talking over 250 years ago. A Scottish philosopher named Thomas Reid came up with an idea that laid the philosophical groundwork for what our modern brain scans are only now just starting to prove. It's an incredible intellectual leap. Reid's big idea was something called direct realism. He argued that when we perceive the world, we're not just looking at a fuzzy copy of reality inside our heads. No, he believed our minds are built to connect directly to the underlying structure of the world itself. He was basically describing a kind of geometric continuity without even having the formal math to back it up yet. And this is the beautiful part. This is where it all clicks together. Reid's philosophy fits perfectly. He said perception and memory are just different projections of the same reality. Projective geometry gives us the mathematical language to describe that. And now, the supramammillary nucleus gives us the biological engine that actually makes it all happen. It's a perfect fit.
Okay, let's take a step back and pull all of these incredible threads together. Because when we do, we get this stunningly elegant and cohesive picture of, well, of everything.
This is the grand synthesis, the big payoff. We're about to see how philosophy from the 1700s, math, modern neuroscience, and psychology are all telling us the exact same story, just using their own unique languages. Just look at how perfectly this all mirrors each other. Let's just take the primary function row. In geometry, the goal is to detect anomalies while preserving structure. In neuroscience, it's to detect novelty while maintaining rhythm. In the human experience of HSM, it's to retain anomalies as structural anchors. It's the same idea, said 3 different ways. It's an absolutely breathtaking correspondence across completely different fields of human knowledge.
So, what this really means is that we have this deep functional alignment across disciplines that, on the surface, have nothing to do with each other. The math gives us the model, the biology gives us the mechanism, and the human experience provides the living proof for a philosophy from centuries ago. It all weaves together. So, if you take one thing away from all this, let it be this. Your brain is not some passive camera just recording what it sees. It's an active, dynamic system that is geometrically tuned to the very structure of reality. And here's the paradox. It finds the truth by locking onto the things that don't seem to fit the pattern. The anomalies are the anchors.
It really makes you wonder, doesn't it? If our brains are using the language of geometry to build a stable world, what other fundamental patterns of the universe are mirrored deep inside our own minds, just waiting for us to find them?